Homework 4. This homework is about Arrhenius equation. In question number 1, it gives you the Arrhenius parameters, including A and the EA, for a first order reaction. It asks you to calculate the time for the concentration change to 1/3. Now this question is similar to one of the questions in the last homework. And as we see, whenever you ask to calculate time, you need to use integral rate law. So for the first order reaction, the integral rate law is ln A over A naught should equals to negative KT. And therefore you can calculate the time if you know the concentration change. But first, you have to find out what is K constant, the rate constant. And the rate constant can be calculated by Arrhenius equation using A and the EA. And the equation is K equals A times e to the negative EA over RT. So plug in all the data. A, this is A. Now EA, your unit is a kilojoule, you must change to joule. So times 1000 to get kilojoule, from joule, a kilojoule to joule. And then divide by RT. RT, T is 300 Kelvin goes to 300 Celsius goes to Kelvin. Okay, and that gives you the K constant. And then go back to the integral rate law. You can calculate the time. So 1/3, which is negative ln 3. Okay, so the time can be calculated. In question number 2, it gives you two temperature, okay, T1, T2, and their corresponding rate constant K1 and K2. It asks you to calculate Arrhenius parameters, including A constant and EA. Now there is one Arrhenius equation include T1, T2, K1, K2, and that is this one. ln K2 over K1 equals EA over R. So in class we derived this equation. ln K2, K1 equals negative EA over R, 1 over T2 minus 1 over T1. And note that this is always final over initial, final minus initial, and there's a negative sign here. Okay, but if you want to remove negative sign, then you have to switch T1 first, T2 second. Okay, so that's like this one. I would prefer this equation. So final over initial, final minus initial, but remember there's a negative sign. So from this equation, then you can calculate activation energy. Okay, so the activation energy can be used, use this divided by everything else. That give you 64.9 kilojoule per mole. Now, how do you calculate the A constant? You have to go back to another version of Arrhenius equation. In this equation, you have both A and the EA. EA just calculated, but you need to change to joule if you have R constant. R is in joule, so this times 1000. Okay, and you can calculate the A constant. All right, so K divided by this exponential. That give you this value. Okay, so that's question 2. In question number 3, it gives you half-life at 2 different temperatures. It asks you to determine Arrhenius parameters. From the characteristics of the first order reaction, we know that the half-life is ln 2 divided by K. In other words, if you know half-life, you know K constant. So from this table, we can calculate the K also, okay, K constant. So K1 can be calculated, K2 can be calculated. And with temperature and the K constant, T1, K1, T2, K2, then this go back to the last question. If you know T1, K1, T2, K2, then we can calculate Arrhenius parameters. So we just calculate K, all right, get a new table. Instead of half-life, we write as a K constant. And then use Arrhenius equation just like last question. We calculate EA, and then go back to another version of the Arrhenius equation. We calculate A. Okay, that's it.